So let's talk a little bit about the sequencing methodology behind System Moffenzeef. Everything in System Moffenzeef is based around the MITO, which is a 6-channel clock divider sequencer that also has swing and control of pulse width. The count is the master clock module and is used for keeping the MITO and the deviant in sync with one another. The main pulse coming from the count goes into MITO so that when the knobs on MITO are all the way to the right, they're equal to what's coming in. You should think of this as your fastest possible note, like your 16th note division. This is the fastest your sequence can go. And the slowest it can go is divide by 16 from that. So I wanted the user to not think about that at all, which is why it's not labeled. And I don't want you to think of it as hard divisions, even though that's what it is. Instead, I want you to think of it as when you turn the knob to the right, it's more complex. And when you turn the knob to the left, it's less complex. And the reason why is because deviant was designed to work in tandem with MITO. So there's a misconception about deviant. People think deviant is a sample and hold module. And if you look at it here, it's not just a straightforward sample and hold. These top and bottom knobs here dictate the maximum and minimum range of the random. So this allows you to create really small windows of random that are tuned to very specific ranges. And that was designed primarily to work with MITO. The idea is that you take this random voltage and now you plug it into 3 of these channels. We're going to do it on the kick and those 2 glitch sounds. And now they're going to rhythmically modulate their division. So every quarter note pulse coming from the count is clocking the deviant, which is generating this voltage. And now these 2 knobs become a macro control for our deviation, basically. So when both knobs are at noon, nothing is happening. When you turn top all the way up, you can see the positive light illuminating. It's generating positive random voltages between 0 and 5, and that's as if you're taking the MITO knob and turning it to the right. And the same is true if you turn top at noon and turn bottom all the way to the left. You can see the minus light is going off. That's like turning the knob to the left or making it less complex. So the idea is you can find a window of basically variation that you like and allow the machine to make decisions for you. So it's happening on a musical grid that you have control over. And then you have the individual ability to change the complexity of each individual drum by turning the knob, or globally with 1 channel of deviant changing all of the divisions. What I often like to do is take the 2nd channel of deviant and use that for timbre variation, which currently is controlling the amplitude decay of the kick drum and also a filter cutoff on the snare drum. It's very subtle, but that's what's happening here. In addition to that, there's also a swing knob on MITO. So I slowed it down a little bit, and I'm going to turn the swing up so you can hear what happens when you get faster notes. You can get these broken rhythms. Let's speed it up a little bit. And that can also obviously be modulated by deviant. So you can have this like weird generative, like voltage controlled slop situation happening, which is pretty cool. So yeah, in addition to that, there's just mutes for every channel right here with these switches. And that's pretty much it.